Now that we have created our first Voronoi fracture, let's dive into the Voronoi parameters and take a closer look at the possibilities of the node. We will also create some interesting patterns based on points distribution. So as usual, let's start with a very simple geometry. I will create a box, dive into the geometry node, and change the size to 8 meters in X, 2 meters in Y, and 0.4 meters in Z. I will also change the center to 1 meter. Now I will lay down my Voronoi fracture node. So I will tab, then type Voronoi, press enter, and connect the Voronoi fracture to my box. So last time we used a scatter node to create our points on the surface of the sphere to generate our fractured pieces. This time I will replace the scatter with a point from volume node, and I will connect the box to this node. So you'll notice how now we have hundreds of points organized in a very regular way. Actually, if we take a look at the front view by pressing spacebar 3, you will notice that this is a grid of points. We can now press spacebar 4 to take a look on the right side. And again, here each point is separated by this value. The point separation here will determine the distance between each point. And this is very useful. So for now, I will go back to my perspective by pressing spacebar 1. And we know that the thickness of this wall is 0.4 meters. So I will change the point separation to half of this value, 0.2, just to have one point centered on the wall, and the rest of the points will be aligned to the surface of the box. So let's connect the points to the Voronoi fracture and let's see what happens. So just make sure to click on the visibility icon of the Voronoi node. Now, instead of having the original cell pattern that comes from a random distribution of points, we have regular squares. In this case, the squares are being generated by this very uniform division of the points. And this is very useful to create things like tiles or bricks or even floor and rock patterns. So before we continue, I want to show you two very important attributes of the Voronoi fracture. And for that, I'm going to lay down again an exploded view just to be able to see the individual pieces. And I will zoom out just a bit. So notice how the exploded view has this piece attribute and it's set to name. So where did this name attribute come from? It was generated when we added the Voronoi fracture. So let me select my box and open the geometry spreadsheet and take a look at the primitives section. You will notice how for now we have no attributes for the primitives. And after attaching the Voronoi node, we have three new attributes. One is the name attribute, and the other two are group attributes. One is called inside and the other is called outside. And these three attributes are very useful when generating our destruction materials or even rigid body dynamic simulations. So let's take a closer look at our geometry. Again, I will go back to my exploded view. And each one of these boxes will have a different name attribute. So let me generate a visualizer real quick. So I will right click on the visualization node, Then I will click on the plus icon to create a new marker. And this marker will show me the name attribute. So type name on the label and on the attribute as well. So let's zoom into the individual pieces. And you will notice how every face of each cube has the exact same name. In this case, piece 304 for this cube. And every face of the cube will share the same name attribute. And again, this attribute was generated automatically by the Voronoi fracture. And as we already know, this name attribute will be very important when we start creating our rigid body dynamics. Another very interesting thing is that the Voronoi fracture has automatically created two groups. And you can see the names of these groups here. The interior group will be called inside. The exterior group will be called outside. And what this interior group means is the new faces that were generated with the fracture. So let's take a look at the exploded view. And I will connect a blast node just to see this better. And I will select the inside group to be deleted. So notice how now we only have the original faces and the rest has been deleted. Now, if we select rather the inside group, or actually the outside group, sorry. Now we are only left with the new faces that were generated inside the wall. And this will become very useful when creating materials, for example, or when creating interior detail for our pieces. So I will zoom out and delete the blast node and go back to my Voronoi. So back to our pattern generation, I will select my points volume node and I will slightly increase the point separation just to have a single row of blocks, just like this. And what I'm going to try to do is to offset a few of the rows to create different shapes. And for now I'm going to delete this scatter node that we won't use anymore. And below my points from volume node, I will create a point wrangler. And another thing I'm going to do is turn on this display point numbers button. You will notice how the first row of points has even numbers, the second row has odd numbers, and so on. So I will use this information to offset every other row. And to do this, I will create an if statement, and I will use a modulo operation to select only the odd numbers. So we can type if at ptnum, which is the number of each point, modulo 2 is equal to 0. Then we're going to execute the following code. V at p, which is my current position, dot x, which is referring only to the horizontal position, will be equals to v at p plus 0.2. So just make sure to close this line with a semicolon and press Ctrl Enter to evaluate. And here on the attribute definition, we need to use a small v, not a capital V. So Ctrl Enter to evaluate. So now notice if we go to our front view, how the even numbered points are offset by 0.2, or if we change this to 0.1, they will be offset by this value. So let's create a channel just to be able to move this interactively, and I will open quotes. It can be single or double quotes. In this case, it doesn't make a difference. I will call it offset and close quotes, then close parentheses, and Control Enter to evaluate. Now make sure to click on this button on the right to create the actual channel that will let me offset the points. So let's go back to our perspective view. Let's turn off the display point numbers and let's click now on our Voronoi fracture. So now we have this very nice hexagonal pattern that can be generated by offsetting these rows of points by exactly half of the point separation. In this case, point 11 would create a symmetrical hexagon. So we can take a look from the front view. So press spacebar 3 and then spacebar F to frame the entire wall. And here we can see the patterns. Of course, if we keep increasing this offset, we can generate different shapes. For example, to create a floor pattern or a wall pattern. Or we could even randomize these points a bit. For example, we could add a point jitter after a wrangler and increase the jitter by a very small amount, just to make these shapes a little bit more irregular.